So let's take another look at the binomial probability distribution. We said with the binomial distribution, we had a series of n Bernoulli trials. Okay, and a Bernoulli trial is one where there's only two outcomes that could possibly occur in a trial. And the outcome is one of those two possible outcomes. So for example, we could be talking about a game where the only result could be win or loss, okay? And only one of those possible results will occur as a result of that game, as a result of that trial, okay? So we know that only two possible outcomes can occur, and one outcome are, well, let's call them successes and failures, okay? Success and failure. Those are the two possible outcomes of our Bernoulli trial. And let's say that a success occurs with probability p. One individual trial will result in a success with probability p, and one individual trial will occur, end with a failure with probability 1 minus p. Okay? These two things are mutually exclusive. We can't have a trial that results in both a success and a failure. And they're collectively exhaustive. Okay? Only these two things can occur. So their sum, their probability sum is 1. P plus 1 minus p is 1. Okay? So now let's say we have n different Bernoulli trials. Let's say, just for example, that n equals 5. Okay? So here are 5 outcomes that are occurring from those 5 Bernoulli trials. Okay? And we know that for each one of these, only one thing or another could occur. A success could occur for each one, and a failure could occur for each one. Okay? And so let's say we have a random variable, x, that counts the number of successes in 5. Okay? So we've got 5 Bernoulli trials. What's the number of successes? That's what this random variable x is counting. So if we wanted to know, for example, what's the probability that x takes on the value 2? Okay? What's the probability that if we have 5 Bernoulli trials, that x equals 2 successes? Okay? Well, what possible combination could we have here such that we have 2 successes? Well, let's take a look at one example. Here's one possible outcome. Okay? The first and the third trials had successes, therefore the others were failures. Okay? Or we could have this. Let's just write this out a little more easily. We could have this as a success, that is a success, therefore these others had to be failures for us to have 2 successes. Okay? Or we could have this. Here was a success here, here's a success here, and the rest are failures. Okay? We could enumerate each one of these possibilities. It might take us a while. Okay? Let's also think about what's the probability that this string of events occur. Okay? We have these 5 trials. What's the probability that we get a success, a failure, a success, a failure, failure in those 5 trials? Okay? That is the probability of success, p, times the probability of failure, 1 minus p, times the probability of success, p, times the probability of failure, times the probability of failure. That is, we see success and failure and success and failure and failure. We have to multiply the ands together. Okay? What is this result? P squared times 1 minus p cubed. Okay? Let's take a look at this one. So if this was the outcome that occurred, what's the probability that this particular string of successes and failures occur out of these 5 trials? That is the probability of success times the probability of failure times the probability of failure times the probability of failure times the probability of success. Okay? P squared times 1 minus p cubed. Okay? And again, what would happen here? We got 1 minus p times p times p times 1 minus p times 1 minus p. What is that? P squared times 1 minus p cubed. So we have a bunch of different possibilities for us to pick 2 successes out of 5. And each one of them occurs with the same probability. So what does that tell us? That tells us that for us to find 2 successes out of 5, first we have to choose which of these 5 are going to be our successes. How many different combinations are there? that we could come up with 2 successes and 3 failures. That's 5 choose 2. 5 choose 2 different possibilities here. And what's the probability of those individual outcomes of those possibilities? P squared 1 minus p cubed. Okay? So the probability that we see 2 successes out of 5, first we've got to pick those 2 successes out of the 5. That success, each one of those successes occurs with probability p. Each one of those failures, there are 3 of them, occur with probability 1 minus p. Okay? Generally speaking, if we have a random variable x, and we want to choose, or we want to find what's the probability that x equals little x, where we have n Bernoulli trials, that is n choose little x, p to the little x, 1 minus p to the n minus x. Okay? This is the binomial distribution. X is a binomially distributed random variable, and this is the probability that x takes on this value little x. How many ways are there for us to find this little x out of n? P to the x, the probability of success to the x for those x successes, 1 minus p, the probability of failures, raised to the n minus x failures. Okay, if there are x successes, there must be n minus x failures. So this is the binomial distribution, and we'll apply this to several examples upcoming.